Welcome to EOS Mathematics. Before today's topic, please subscribe and hit the bell icon to get notified of our upcoming videos. Today we are going to be talking about mensuration of cycles. A cycle is regarded as a set of distances around a point. Here we see the radius and the circumference, which is also regarded as the distance around the circle. We also see the sector, which is marked in green, and the segment, which is marked in blue. By now we know that the formula for the area of a circle is pi r squared, where pi is an infinite number and r is regarded as the radius of the circle. The area of a sector is equal to theta over 360 times pi r squared, where pi r squared is the area of the circle and theta is the angle subtended at the center of the circle. Now let's see the perimeter of a sector. The perimeter of a sector is equal to 2r plus the length of an arc. Remember, we need to know about the length of an arc. The length of an arc is equal to theta over 360 times 2 pi r. Remember, 2 pi r is the circumference, or the formula for the circumference of a circle. Perimeter of a sector is equal to 2r plus theta over 360 times 2 pi r, where we have r as the radius and theta as the angle subtended at the center of that particular sector, or the sector of the circle. Now we want to see the segment. The segment also has an area and a perimeter. Now the area of a segment is equal to the area of the sector minus the area of a triangle. Now here's a diagram. We have a sector which we crossed with a chord. Now the chord gives us, yes, it's a sector, but we have that sector minus the triangle gives us a segment. Therefore, the area of a segment is equal to theta over 360 times pi r squared, that's the area of a sector, minus 1 over 2, that's half of the radius squared, times sine theta. This is one of the formulas of the area of a triangle, where we have theta. Finally, we want to see the perimeter of a segment. Remember, a segment consists of a chord and the length of an arc. So when we want to see the distance around the shape now being the segment, we have that the perimeter of the segment is equal to the length of the chord plus the length of the arc. Now, in a separate video, we are going to be talking about the length of the chord. But for today, we are going to know that the length of a chord is equal to 2r sine half of theta, that's half of the angle, plus theta over 360 times 2 pi r. A quick recap. First of all, we talked about circles. Next we talked about sectors, the length of an arc, and finally we ended with the segments. If you liked this video, please hit the like button and share with your friends. See you next time.